Welcome to Time Series Data New York number 3. This is our third meetup event. And before I kick things off, I just like to get comfortable with who I'm speaking with, break the ice for our main speaker. What brings everyone here today? Just show who's feeling particularly friendly and wants to.
Start off.
Great, awesome.
I'm Arnab. I'm a quantitative analyst.
Yeah.
Hi, it's good to see you all here. Thank you, Andrew.
Yeah, sure.
My name's Arnab. I'm a quantitative analyst by trade, and I've been using time series. So when I realized there's a group meetup, I was like, why not meet other smart people who enjoy this? So that's why I'm here.
Everyone should be that friendly, okay? That's awesome. Anyone else? What brings you here?
I really enjoy using Postgres, and I heard Timescale came out with the v1.0 recently, so came to learn more.
Awesome. Cool. Then you came to the right place. This is going to be fun. We'll get into Grafana and how to graph time series data in Postgres in Grafana. So yeah, before we move further there, just an announcement. If you're interested in time series data, you might be interested in an IoT New York, in the IoT meetup that we were on, IoT New York. And that's just kind of any company involved in IoT, which could be a lot of them across all different industries. IoT data is time series data, so there's kind of a natural, we run that meetup, and Timescale kind of has a natural place there as our database is used in IoT. So a lot of really cool companies come and speak there. Really great speakers. The next meetup is about decentralizing IoT and disrupting the telcos. So Helium, if you're familiar, has been they've been around for, I think, like 7 years now. They've pivoted, and now they're running like a blockchain-based communications network. So that's October 4th, 6 to 8 at Grand Central Tech in their build space. Head to meetup.com/IoT New York to RSVP. The agenda for tonight, we've networked and had food and drink. We're in the welcome portion now, getting started a little bit late, and then we'll hear from Diana in a few minutes, who's our head of product at Timescale, and then we'll continue to network. We have to be out of here by 8, so we'll leave at like 7:50, and we're going to go to a bar just up the street and continue to hang out for anyone that wants to. So yeah. Tonight's speaker is Diana Hsieh, head of product at Timescale. Follow her on Twitter. She's like super active on Twitter. Previously, Diana was product manager at Cockroach Labs. For anyone familiar with CockroachDB, they build a globally distributed SQL database. It's really cool stuff. Diana, before that, was an associate at Norwest Ventures, and before that was in investment banking and their technology, TMT, at Morgan Stanley. Lastly, thanks to our sponsors, 2 Sigma, for allowing us to have this space, and NEA, another one of our investors, for supporting our meetup activity. 2 Sigma and NEA are both investors in Timescale. They're super supportive. We're super lucky to have them. So let's give a round of applause to 2 Sigma and NEA. And then before I hand it over to Diana, we heard from 2 of you. For those that didn't raise their hand and share why they're here, if you have any questions, those Post-it notes, you can go ahead and scribble on those. We'll collect them, and we'll get to your questions at the end as best we can. Without further ado, Diana.
Hi, everyone. I do want to clarify some points about my bio. I am not active on Twitter, so if you tweet me, I will not respond. I probably check like once a month or something. And right before this, Andrew was like, I pulled your bio, and are you sure you want to tell people you used to work in finance? And I was just like, well, I have a funny story because I view that as a dark side of working in finance on tech companies, and now I'm on the bright side where I work on open source software. So I definitely really enjoy working on open source software. Not to offend any of you finance people, but you weren't in investment banking, hopefully, so I feel like it's a different industry. Cool. So can you see this? Yes. So a little bit about me. Andrew already kind of talked about it, but basically I've worked at 2 different open source companies at this point, both databases. Really love the space, so if you want to talk about open source, databases, time series, use cases, feel free to come find me after this. But I also have a flight later, so I might not be able to stay very long. All right, so Timescale. We are an open source time series database powered by Postgres. I'm going to move over because I'm short and I feel like I can't see you all. We'll talk a little bit about what it means to be a time series database, and we'll talk about what it means to be powered by Postgres, but we're going to talk about that later. One thing I wanted to share is some exciting news. Timescale just released the 1.0 release candidate, and what that means is it's a release candidate that we think is almost fully baked. We just want it to be in the wild, to be tested a little bit more. Yes, that's great. But what does it even mean for a database to be 1.0? It means we view ourselves as production ready. So we have a lot of really great users who are using our product. Just diving into a couple of these users, Cray, supercomputing company, they're using Timescale to monitor the different supercomputers that they have in the wild. And Leica is a use case that I really like. To protect your eyes from blue light. Anyway, production ready. Leica was the other use case I had wanted to share. They started out using us for DevOps monitoring. And after they realized that having all this data in a relational database was really useful, they started ripping out a bunch of other NoSQL databases and swapping over to Postgres and Timescale. So I think it's a really great land and expand story. The other thing that we view as important to 1.0 is being performant for the use case that we've chosen to optimize for, which is time series. We've done a lot of benchmarks. These benchmarks are very rigorous, very detailed. There's information on what machines we used, what schemas we used, all the different patterns we tried for all the different databases that we've chosen. So I'd go check out our blog for that. We also open sourced the time series benchmark suite that we use to do it. So if you want to test your hardware and figure out what kind of hardware you want, you can download this and try it out with your hardware as well. And finally, we're going to talk today about the first one, Grafana. The second one is another thing that we released kind of in the 1.0 timeframe. Both are TimescaleDB integrations, and what it means is we actually had engineers internally work on these 2 different integrations to make it work better for Timescale. So with Grafana, it's a connector that has TimescaleDB functionalities, as well as a visual query builder, which we will demo later. And with Prometheus, it is a Prometheus adapter. The Prometheus adapter allows you to use Timescale as a long-term store for Prometheus, and you can query both Prometheus or Timescale for your metrics. So the 2 different integrations that we built in the 1.0 timeframe. One thing I did want to remind everyone of is because we're built on Postgres, tools that work with Postgres also work with us. So this is just a subset of kind of some of the tools that you can actually connect with Timescale, and you can expect them to work the same way. So I have an agenda because I'm a PM, and all PMs always have an agenda. We're going to talk about what is time series data, which I'm sure a lot of you already know about, but I think we do have some interesting ways of thinking about time series data, why you should even care about time series data, how Timescale fits into the time series use case, and then we're going to have this demo where we're going to visualize time series with Timescale and Grafana. And this is the first time we've done this demo, so it's exciting. And it might also mess up, but we'll see. All right, so starting with what is time series data. I kind of think of it in this way. You have some data that's being collected from multiple different sources. All of this data has some kind of timestamp. It's usually ordered by time. So you might have data that came in 5 hours ago, and you'll have data that comes in 4 hours ago, and so on. So that's time series data. It's quite straightforward. So any kind of data that has a timestamp, and typically it comes in a time order. So you're probably asking, why do you even need a database just for time series? I think it's very common to store time series in just relational databases or NoSQL databases. And part of it is because I think previously time series was initially a pretty niche market. People didn't necessarily view it as a huge use case. But what we're starting to see is that how people store data is changing over time. So in the past, maybe you had a relational database and you're storing the current state of something, like a snapshot. So if you're a bank, you're storing all of the accounts that your customers have and the current balance of the accounts. Right now, we're seeing people have a relational database that stores the account balance and then a separate database, maybe a NoSQL database, that stores a transaction history. And that transaction history has a timestamp associated with each transaction. But that kind of has this problem of now you have two databases. You can't join across the two databases. It's kind of a nightmare to manage. So what we're seeing today, and what we hope to see everyone evolve into, is this world where everything is timestamped. You're storing the history of everything that has ever happened, and you can kind of recreate a given point in state based on the timestamps that you have. So from our point of view, we think time series data is super important. It gives you a holistic view of kind of your entire data lifecycle, and you can do long-term analysis from the past data you have. You can use that past data to inform present insights, and then you can also predict the future based on the past. So one little tidbit about why now is the time for time series. Well, as you all know, we're generating more data. I think a lot of people like to talk about IoT as the most common use case for generating data, but this actually is true across all different industries. You have DevOps, where they're storing more data from DevOps, they're collecting more data. You also have web applications, where web applications are storing user data. When did a user log in? What did they do? All of that is time series data. I think at this middle layer, you have a lot of companies like CockroachDB, where I worked at, and also Timescale, where we're trying to optimize for these things, and we're optimizing for these things on better hardware. So compute is cheaper, storage is cheaper, and all of these things make it possible to actually store all of this data that's being generated. And what this has resulted in is data as a standard. So everyone needs data. It's a competitive differentiator. If you don't have it, you're lagging behind. So ultimately, we kind of view this as the new world paradigm. And I know that's kind of a marketing word. So why should you care about time series? This kind of goes back to what we just talked about. Previously, everything was stored as a snapshot. So we had this example of financial data being stored as a state snapshot of all of the different balances that all of your customers have. But the time series equivalent of that is a history of transactions. Within the DevOps space, maybe your snapshot is how much of my CPU is utilized right now. But in the time series use case, you have how much has my CPU utilization changed over time. Within IoT, maybe you have how many online devices there are right now. But what you want to know is how many new devices have I added over time? And within SaaS applications, you have total users of your web application. But you actually want to be able to understand how the logins of my users changed over time. So you can kind of see how all of the data that you typically historically thought were snapshots, state data that weren't time series, can actually be converted to time series if you're actually collecting the changes over time. And what this gets you is, once you store this time series, you can actually do more interesting things with the time series. And this is a story that we've heard over and over again with our users. First, they just want to be able to store their time series somewhere. Then eventually they realize, oh God, I can do ad hoc SQL analytics. I can visualize things. And now I can show this visualization to my CEO to show him how my hardware is being utilized. I can store my machine learning models. I can automate things. So this ability to store time series really opens up a lot of new use cases where all of these use cases require some kind of history of data. So I'm going to talk a little bit about Timescale and how we fit into the overall time series ecosystem. And if you have any questions, feel free to write them down in your Post-it notes, or anything that is not clear, definitely happy to clarify it after this talk. So I just wanted to remind everybody, in case you forgot, open source time series database powered by Postgres. And now we're going to dig into both what a time series database is and what it means to be powered by Postgres. So what a time series database is a database that is optimized for time series. And in this graphic on the left, you have a lot of data that's being ingested. On the right, you have these squares that we call chunks. These chunks are partitioned either by space or time. Typically, they're partitioned by time. And we have a hypertable abstraction that basically makes all of these chunks look as if it were just a single relational table. And what that gets you is the ability to ingest millions of data points a second, and this is something that we've benchmarked. You can also scale to hundreds of billions of rows, And you have this nice SQL API on top because of this hypertable abstraction. And we have built additional time series functions that make it easier to actually work with time series. A little bit more about hypertables. Hypertables are really just appear to be Postgres tables. And one of the reasons why is because chunks are actually functionally very much like a Postgres table. So we just persist different actions down to the chunks, but at the top level, we still look like just a table. So that means your hypertable can support indexes, it can support triggers, constraints, foreign keys, upserts, out-of-order data. You can do DDL schema management on it. So it is literally just a table, but underneath, we've optimized it for time series. So how do we actually do it? We built on top of Postgres, and I think this is actually a really interesting fact about Timescale, that what we've done is by building off Postgres, which has been around for over 20 years, we were able to kind of have this reliability built in. So the storage layer at the very bottom is just the Postgres storage layer, and that storage layer is very reliable and has been tested in production for a very long time. And Postgres is surprisingly extensible. So the next layer on top that we've optimized is the schema management layer. And what we do here is we break up data into chunks, which we talked about earlier. These chunks are usually partitioned by time. The time-based chunks do not have to be the same size, even though they're drawn the same size here. But this is all done automatically and transparently, so we manage all of that for you. And because things are ordered in chunks, you can also manage your time series a little bit better. So if you want to drop a given range, you can just drop different chunks, and that's much more efficient than going through and deleting every single row where like a timestamp equals blah. On top of the schema management layer, we have the query planner. The query planner includes both timescale queries as well as standard SQL queries. So these orange blocks are time series optimized queries. The blue ones are just standard SQL queries. So what this means is you can run basic normal relational SQL queries. But if you run a time series query, Timescale will know to optimize it by excluding chunks based on time. Finally, on top of this, we have this SQL API. The SQL API, the blue part, is what Postgres offers, full SQL compatibility. And it also includes things like JSON, PostGIS, and all of these different extensions that you've come to rely on with Postgres. And on the side, we've built these time series functions that combine with the SQL API to create kind of a more robust language to express time series queries. Does anybody hear that bass? I just want to...
Oh, it's not part of the...
No. I just wanted to calibrate. I'm like, is something going on here? OK. So anyway, what this all means is that if you go back to this image of how we view the ecosystem, you're collecting a lot of data at the top, and this supports really fast ingest. At the middle, you have this relational time series database, so you can use SQL, but have time series capabilities. And historically, relational databases have not scaled well for time series. So now you can actually have SQL with your time series data. And then at the very bottom, now you can support analytics and visualization tools that work with Postgres, because anything that works with Postgres also typically works with Timescale, with a couple exceptions. Great. So this is what I feel like is more interesting to me. This is new to Timescale. So within our new release, we introduced both a Postgres data source, which is part of Grafana. So we actually gave it back to the community. It's open source. It's part of Grafana. So when you download Grafana, it's built into the Grafana software. With this new Grafana release, which is going to be coming out in a couple weeks, it's currently in beta. We also introduced a query builder that's visual. So for people who aren't as good as SQL, you can do a drag and drop interface. So we are going to demo that, and we'll see if it works as expected. A little bit about Grafana. I don't know how many people use Grafana, but hopefully most people are familiar with Grafana. It is a very powerful dashboarding tool. It has alerting features. What I love most about it is that it's open source. That means we can build on top of it, we can contribute things, and we can kind of make it fit how Timescale thinks about time series. And it's also very extensible, so you can install packages that other people have built on top of Grafana. It's a very cool tool. What we had before and what's currently in Grafana right now is this PostgreSQL data source with support for Timescale. So essentially, you can run SQL queries that power these nice dashboards that are shown on the right. And this means you can just run SQL queries the way that you would typically run SQL queries. But what we realized is there's this really interesting use case that people have been using us for, which is storing operational metrics. So not everyone uses a stack because some people have their own proprietary pipelines, but a really common stack is Prometheus. They'll use our Prometheus adapter. So the Prometheus adapter will write any of the metrics that come into Prometheus into Timescale and use Timescale as a long-term data store. And on top of it, they'll have Grafana, which can either query Prometheus or it can query Timescale. And what people have realized is that by storing all of this data, they have this historical data that they can use to measure trends. They can go back and see when that occurred, what were the metrics. Whereas if you only have Prometheus, it's not really built for long-term data. So if you don't go and look at the metrics before Prometheus wipes your metrics, you might not be able to actually do that incidence analysis. They also realized that now that they have Grafana sitting on top of Timescale, they can share all of the metric dashboards they have with the business analysts who might not necessarily be super savvy at connecting to Timescale. And we wanted to meet that use case, the use case of where maybe someone was really familiar with Prometheus but doesn't really understand SQL very well, so they want to just have an interface that it's easier for them to write SQL queries. So coming up in Grafana 5.3, and this is actually downloadable right now, the beta is available. There's a graphical query builder. So it's playing right now, yay. Graphical query builder and also time series macros, and we're going to talk about exactly how to use that and what it looks like. So the demo that we built, all of this is fake data, just FYI, is TigerWeb. TigerWeb is this website that lets you sign up to track tigers. And we're just going to talk about two different data sets here. The first data set is the DevOps data set. And obviously, if you're in DevOps, you probably have more than just CPU utilization as a metric. But in this case, we're just trying to keep it simple. So you have a table. It has a time column, which makes it a time series. It has a server ID, and then it has the CPU utilization column. And for people who have read SQL before, I also included kind of what that looks like in the actual terminal or pSQL interface. There's also this other second set of data called users. The users table is grayed out because it's just a standard relational table. There's an ID, a username, and a country. And on the usage side, that is a time series. So there's time, what user came in, how long their session was, and what their request type was. And if someone had a session length, they don't have a request type. So we'll talk a little bit more about what that actually means and how Postgres is actually well suited for these types of sparse data sets. So yeah, relational table. Sometimes I forget the things I put in here. So one thing to note is it's OK to have foreign keys. So this is the usage table. There's the time column, the user ID column, the session length, and request type. And if you look down, there's the foreign key constraints. The foreign key constraint shows that you have the usage table. Its ID actually references the ID in the users table, which, if you remember, was actually a relational table. And if you look at the users table, you can see that down here, referenced by, that's just all of the different chunks that are referencing the ID that's stored in the users table. So indeed, the foreign key constraint actually is there and is working. So we talked a little bit about sparse data. I had said if a user has a session length, they don't have a request type. The point here is that it's OK to have sparse data. So Postgres actually stores null data types very efficiently. So you can have multiple columns. The columns don't have to be filled, and it is actually still efficient. All right, this is when I move over to my demo. We'll see if this works. Let me hide some of these things. You know what? Let me unplug for a quick second, just in case I show something that I should not be sharing, because I realized I didn't open my Chrome. Wonderful. OK, I'm just going to open a new window because OK. Cool. Working. So the first thing we're going to do here is go into this dashboard. And for people who've used Grafana before, I'm sure this looks very, very familiar. The first question we're going to try to answer is based on the 2 different tables that I just shared. Well, technically 3, but the 3 different tables I shared. How do I know whether or not I have enough CPU to actually support my users? So what you can do here is you can add a panel. And I'm using the beta version of 5.3, so this isn't a stable release, just FYI, but it will be soon. Oh, sorry. What? Make it bigger? Is that better? OK, so I'm going to add a panel. Oh, yes, that looks way better. And I'm going to add a graph. OK, so in my graph, all you do is click Edit. And when you click Edit, this query builder that we've built comes up. And it autofills. So it tries to find the table with data, and it just tries to autofill it. So if you come down here, we're selecting from the DevOps table. We're using the time column time. We're selecting the CPU utilization metric. And we are filtering by this macro. This $ represents a macro. It's filtering by time, and it's basically filling the values that come up from this top toggle. So this is just kind of what Grafana looks like, and this is our query builder. So one thing that you might notice about this graph is it's kind of useless because there's so much variance in the data. So what you can do is maybe you're like, well, I don't actually need to see every single data point that came in at every single point in time, so I can actually group by time. And here, it chooses a default of, I think it's like somewhere around 5 to 7 days. But you can define your interval. And when you define your interval, maybe I want to just see, over the last day, what is my average CPU utilization? And let me see that daily average over an entire year. So this just shows you that. It's that easy. Now you can see the average CPU utilization over a year, and it's averaged by day. Cool. So one thing you might notice is I put in 24 hours, and you'll wonder, why 24 hours instead of 1 day? So the way that Grafana parses this group by, it only supports, I believe, let me see, seconds, minutes, and hours. So what you can do here is Timescale has a specific time series function called time bucket. And what time bucket does is it allows you to specify arbitrary periods of time. So instead of doing something like day, you can actually do 3 days or 5 days or 7 days. So we can try that here. So when I try, the reason why I pulled this generated SQL is like maybe you don't actually know what the formula looks like and you don't know what the query should look like. So you can actually copy it from the generated SQL. So I'm going to come here and toggle the edit mode, and this shows you the raw SQL editor. And this is what existed in the current version of Grafana. So what I can do here is copy this over. No, go back. And change this time bucket to 7 days. And I click out here, and it'll recalculate everything. So you can do 5 days, 3 days, whatever you want. And that's kind of the beauty of the time bucket function. And that comes with Timescale. Great. I did also want to mention that Timescale has some other time series specific functions, like first and last, and all of those are supported with the current Grafana release. Yes?
The group by right there, is that the group by one?
Great question. So you're asking what the one means.
Is that the column?
That is, it's the first column shown in the select statement, so that would be time bucket. So you're grouping by time and ordering by time.
What was the question?
What does,
What does the one stand for in group by?
yeah, the question was what does the one stand for in group by? But yeah, like, for example, Grafana has some specific like macros and stuff like that.
Does it have to be a number too, or can you just group by time as well?
You know, I've never tried doing group by time. We could try it and see what happens. Yeah, that seems to work. Oh, never mind. Don't do that. Yes, this is definitely a kind of, yeah, I would stick with whatever the generated SQL shows you, because I think Grafana does different things behind, just underneath the layers. But your question was?
What is the data type for timestamp?
Oh, the timestamp? It's just a timestamp, no time zone. You can use the time zone if you want to. but this is a very simple data set. So great. OK, so we kind of talked about how you could use timescale and the time bucket function to group differently. So I'm going to change this back to the query inspector and change it back to 1 day, because I wanted to show you that you can also use window functions. So within here, you can use window functions like increase and rate. But based on this data set, those graphs kind of really didn't show me anything interesting, so we're not actually going to graph those. So that was kind of how you can see how much capacity am I using, and how has that trended over time. And the next question you might want to ask is, how does the overall time that my users are spending on the platform correlate with capacity? So is it true that as more people come onto the platform, my CPU utilization goes up? And I will tell you it is true, because I forced the data to show this. But we'll show you kind of how to do that. So you can actually add another query here. And instead of querying from DevOps, we're now going to query from that usage table. And it autofills a column of session length. And what we want to do here is, maybe I also want to group it by day, because I already know that my time period is a year long, and it kind of makes the graph look weird. So I'm going to group it by a day too. And maybe instead of the average, I actually want 24 hours. I actually want the count, or the sum. So how much total time over the last day has any given person spent on my platform? So I can actually change this. I'm going to remove these things, and it gives me some error messages because I haven't fixed this yet. So I'm going to aggregate by count. Oh, sum. I said sum. Aggregate by sum on a 24-hour basis, and I'm going to graph that. Let's go up here. So this graph looks like crap, because the two different y-axes are too different, right? So Grafana has this nice thing you can do, which is I actually just want to graph my session length on the right axis. And so now you can see that correlation. As my users increase, my CPU utilization also does increase, but it increases at a rate slower than the increase of my users. That's kind of what you can get by correlating two different time series metrics from two different tables. All right. Yes?
To do what you just said, you need a common field between the two tables? At least one common field?
Well, so you have to have time so that it graphs by time. So that's the common field in this case.
Okay.
Yeah.
Time is always the dependent variable, right?
Yeah.
No, it's time series.
Time series, timescale. But we will do a case where we do a join, but that's coming up. Stop predicting my presentation.
Okay.
OK, so now we're going to hide everything, and I just wanted to show one last thing before we do what we just talked about, which is I had that user table, right? And I want to know how many users came in, and how many of them actually signed up. So you can write queries like that too with this SQL Query Builder. So I'm going to pull from usage, and sorry, actually I realized we're here. We're doing the join. So this question around how many users signed up. So let's kind of go through that use case a little bit, because it is a little bit more confusing. Oh, good. I did not really reveal my private key. We're clear. OK, so let me just clean this so that nothing happens. Yeah, I feel like the internet kicked me off, and now I have to sign back in. It's like frozen. So because this is frozen, I'll just show you the slides instead that I had as a backup. Yeah, my terminal is just very, very, very sad. But essentially, if you remember, we had these two different tables. We had a usage table, which was the time, the user ID, the session length, and the request type. And we also had the users table, which was, and this is what it looks like. So basically, you have kind of a different request type. So what we can do actually here is query how many users came in and tell me the count of people who actually signed up. So going back to my Grafana, it was there where I expected it to be. You can change this to user ID. You can aggregate, and you can count how many signups there were. And you can actually do this where clause, so you can have an expression. And in the expression, you can say, well, the request type is going to equal sign up. And now when you go up and look at the graph, this will show you all the users who signed up. OK, so now we're going to do the join. The join basically helps you answer interesting questions where you might have to join data between two different types of tables. So back then, we had this user table. The user table is relational. And then we had this usage table. And the usage table is the time series table that you want. And if I wanted to ask a question like, how many users signed up, but tell me what country they were coming from, I can no longer just query the usage table because the usage table doesn't include the country of the given user. So what I need to do is I need to do a join between the relational users table and the time series table of usage. So I'm going to go ahead and show you how to do that. And the reason why I find this to be interesting is that, yeah, we have this query builder, but actually underneath you can write whatever kind of SQL query you want. So let me go back to toggling this edit mode. And here I have this time group alias, which was bucketing things by time. We have the count of all the user IDs. And we have this filter of the request type, which is sign up. So now I'm going to want to join this usage table with the users table. So hopefully my terminal is back because I had this hidden somewhere in here. Ah, here we go. OK, so I'm just going to copy this query in. It's actually essentially just the query that you see here now with a join. And we can kind of walk through what it means. But here, when you do a join, you have to have two IDs that have the same value. So the usage user ID, which was a foreign, the user's ID was a foreign key that the usage user ID referenced. So you can actually join on those two columns because they are equivalent. And when you join them, then you can pull columns from both tables. So I can pull the time, I can pull the count of the user ID, I can pull what country it was from the users table. And then I can also still filter by request type. So now I can see, OK, out of all the signups that came in, count them, but also group them by country. So let's run that and see if it works. So yes, here. The data I created was kind of a stupid random generator, so that's why it looks very similar. But here you can see that we have 3 different lines. You have a UK line, a US line, and a China line. So that just shows you how you can kind of graph different things, group by different things, combine them with relational tables, and get more interesting graphs that show you how your product is performing or how your DevOps monitoring environment is performing, whatever you want to do. Great. The one last thing I did want to show you is gap filling. So one common problem people have with typical visualization tools is if there's this like big gap in their data, it ends up looking like a 0, or it doesn't interpolate. So Grafana actually comes with interpolation. So I'm going to do something that kind of makes me sad because it takes a long time to generate this data. But I'm going to run a delete if it will let me. Let me just open up another terminal because then things will be better. And sorry, let me just copy this over from my. OK, I can't find my table, so we might have to just give up on this. What did I call it? XD work? Okay, whatever. We're going to move on. That's what happens when you have live demos. Nothing ever works the way you want it to. But essentially what would have happened is I was going to delete this huge chunk of maybe for example, someone accidentally deleted the month of March. You can actually go and delete that, and what Grafana will do is draw a straight line that goes from the last point observed in March to the last point observed, to the first point observed in April. So even if your graph is kind of it's not going to be pretty anymore, but Grafana will do that gap filling for you. So it will do an interpolation between 2 points. So that is actually all I had. I did want to cover just some highlights in terms of, let's just go back here. I'm sorry. This always happens. Just a quick summary. So Timescale, I know I already mentioned this a lot of times, but hopefully you guys will leave and not forget. Open source time series database. Grafana, open source visualization application. So by combining both Timescale and Grafana, you can visualize time series metrics over longer periods of time, and you can store all of those time series in Timescale. And the added benefit is it's all open source. So last point here is we are open source, like I just said. You can go to our GitHub, clone it. You can download binaries. It's all open source, free. You can use it. You should also join our community, slack.timescale.com. Everyone in our company actually takes different days in which we monitor the Slack community. So some days you might hear from me, some days you might hear from Andrew. So you'll definitely hear from people that you see here, because we do actually monitor that community. And that's it for me. Questions?
Any other questions? No?
Are we looking for a table?
Is that looking for a table? I just couldn't find the database anymore. Oh. I was like, where is it? Anyway, whatever, it's fine. Okay, while she's collecting, why don't you go ahead and ask her question?
I was curious about the way the data is stored.
Yes.
Because I've seen it, I don't know if it uses H5, if you can use H5 and things like that, like tables and binary formats for numeric data, text formats for text data, those types of things. I know it's time series, but I'm just curious about that. So I have the time series, it's each column is
Repeat the question,
data stored. So I think I missed the part about why it's fast.
Why what?
Why is it fast, and what?
Okay,
yes. How big is big?
We did not dig into a lot of the technical details around why it was fast, so it's not, that's why you didn't catch it. So the question was, I think I'm going to parse it into two questions. One was, how do we store data, and what types of formats can we store it in? And the second one was, why are we faster? Yes, I can also answer that.
Is there where's the efficiency? What makes it fast?
Yes. So we store data using the Postgres storage layer, so it's not unhookable. Like, you can't point it to S3 or point it to some flat file. You have to store it in the Postgres storage layer. The second question you had was, why are we faster? Yes. So we have time-based chunking. And what this does is, traditionally, like if you have a relational database and you're storing a huge history of time series, right, that table gets huge. And Postgres is building these indexes on top of that table to both insert and read data faster. And what happens is, as this index grows bigger, your large table also has a very large index, and this doesn't live in memory anymore. So you're going to be swapping things in and out of disk. And the problem with that is disk is obviously slow, and you want things to live in memory. So because we chunk things by time, and because time series typically come in time order, you chunk the most recent time series in a smaller chunk, which is conceptually kind of like just a table. And that index will be able to live in memory and support faster ingests.
Just the time series, instead of being a row, becomes a column of a slice. And then you pick the slice you want first, and then you have the column, and then you're going way faster than you would in Oracle or anything else that's going to go through every row or column just to find the time
Well, Oracle will still, if you index based on time, Oracle will still be able to go in. It's just that when you're looking at the index might not be in memory. So you're going to have to go into disk to find the index. Yes, yeah. And I think your third question was, oh, how large can we go? So we are currently single node. What that means is a single node can accept writes, but you can have read replicas. So if you want to have a lot of reads, like you want to have some people doing analytics, you don't want them to kill your production database, you can have read replicas. So I think the theoretical limitation is how big of a disk can you connect to a given machine. We see people go up to tens of terabytes. There is the streaming replication tool. Yeah. Okay. So we are going to go through these questions. Let me filter some of them if they're inappropriate. Okay. Any pros and cons of having hypertables alongside traditional tables? That is a great question. No. If you have traditional tables that are stored alongside hypertables, they will behave as if they were just, a regular Postgres table. The one thing to keep in mind is if you're doing this kind of query where maybe all of your metadata lives in a relational table and you're going to select from the relational table first and then do a join across your time series, you just want to make sure that the RAM that you've allocated can actually store both the metadata table and the entire hypertable in memory. Otherwise, you're going to be pulling the metadata table from disk. Just some things to think about. One thing we also do see is some people might cache the metadata table on client side and then just update if they think the metadata table changed. It's typically small, but sometimes someone might have like 1 million devices. So like they'll have like a device ID and then they'll store additional metrics about that device ID in a different relational table. And that table has 1 million rows. And that's kind of like a little bit on the larger side. Just depends on how large your rows are. Or how many devices you have. We just see people do crazy things sometimes. Postgres is not a column store. It is a relational store. And yes, it does have columns, but the columns are not stored in the same way as a columnar store is. So this person has a second question. Does time have to be unique? I thought I saw a unique constraint in one of the slides. OK. I actually put in the unique constraint just to make things easier for myself. The timestamp does not have to be unique. The one interesting point to note is, so I put in the unique constraint because the way that I was generating this data would have caused a lot of the same timestamp. And Postgres, based on how they build B trees, sometimes having a bunch of the same timestamp creates a lopsided B tree. So there are just different ways to index. So if you're going to just have a bunch of rows that all have the same time, you want to index differently. Like maybe you don't want to just index on time, you want to index on time and like device ID. So combine 2 different columns. Alrighty. Yes.
A couple of technical questions, and
Yes.
then maybe we'll be able to answer it.
Yes.
Okay, the first question is, what's the difference between timescale charts and the traditional partitioning? Yeah, PostgreSQL.
Yeah, no, I was asked to write boilerplate questions if no one had questions. That was my question too. It's a great question. Postgres partitioning, I think in PG11, I don't remember exactly what they call it, but I think it's like declarative partitioning where you can like define some kind of way to parse when a partition is created. The difference there is Postgres partitioning is still largely very manual. So you're creating these manual chunks, they're not dynamic. The query optimizer is not optimized to exclude chunks. So I think that creates 2 main problems. One is it becomes manual, it's very difficult to handle over time, whereas Timescale will adaptively chunk things. So like if you start increasing data and you have more data, you can actually make the chunk size smaller. And that's very easy to do in Timescale. The other side is that we actually have created performance optimizations around chunks that are in the thousands. So maybe you have like thousands of chunks, and you have to be smart about which chunks to exclude when you run queries. And Timescale has built that kind of intelligence around figuring out which chunk to actually pull from, whereas Postgres has not. Yes, that's so many good questions. Postgres is compatible, Timescale is compatible with 9.6 and up, and not 11, so 9.6 and 10. 10.3, I think, is what it's on now.
About performant ingestion, data ingestion, does it mean that you have something innovative around Postgres data storage, or this chunks? It's actually just regular tables with the same limitation of write-ahead log and other stuff.
Yes, we're still using the write-ahead log. I think it's a benefit, and sometimes makes our lives really hard because we have to figure out how to work around Postgres. But because we have the write-ahead log and it's conceptually very much like a table, we actually support like streaming replication and all of these different things that Postgres has that rely on these different things. So it comes with benefits as well.
The main benefit of Timescale in terms of write performance is that your data is separated into separate chunks.
Yes.
And that's why your indexes are smaller, and it means that you don't need to rebuild it and the whole big index, just the small one.
Yes.
And that's the main benefit of write performance.
Precisely. Yes, so I'll repeat that.
Say it again.
Yeah, I'll repeat that because I think it's quiet and I have not been repeating your questions. So he was basically saying the benefit of Timescale is really fast ingest, and the fast ingest is supported by breaking data up into chunks so that the indexes you build are smaller and can fit in RAM.
Batching.
Yeah, I think the benefit of all of this is if you think about like Postgres, you wouldn't see like 50 terabytes with like 8 CPU and like, I don't know, like 32 gigs. But it's potentially feasible with Timescale because you're only really writing into the most recent chunk.
Yeah, I totally agree. Whatever, you don't have to have a huge memory in order to open or even query a huge.
Yeah, so memory just is a function of ingest and basically your write workload. So that's how you typically would think about memory. Okay, let me see. Is Timescale used for events, and would you recommend using Grafana for events too? Yes, Timescale is used for events. We do have people using it for that exact use case, mainly because events also have a timestamp, and often you probably have relational data attached to the event, and you want to be able to query some interesting things. Grafana with events, I think Grafana is a really great fit for, we kind of talked about, in this use case, users signing up, I kind of view as an event. So it just depends. I think Grafana doesn't do well if your event isn't numeric. So like, you would have to count on a non-numeric kind of event, right? Like you wouldn't use it for like full text search or like full text events where you have text or logs or something like that. But if your event is something that you want to aggregate on, then you could build dashboards like I did, where you can count how many people came in and logged in, what country did they come from. Oh, I have to answer this last question, because otherwise you'll think I ignored it. What is your opinion on Influx? Such a great question. So I think Influx, I have a super high respect for that database. I used to work at Cockroach where they were building an entire relational database from the bottoms up. And I think Influx is doing the same thing. So I think what they're doing is definitely kind of super commendable. I will say that I view the two as slightly different types of databases. They're both time series databases, but Influx is NoSQL. It doesn't support it. They have FluxQL, but we know every single database has some kind of QL that looks like SQL, but it's not really SQL. And it's not just about the fact that you want a SQL query language. You want something that is compatible with the ecosystem, that works with the tools you understand. So for me, I think just having this full SQL compatibility means that you can use tools like Tableau with Postgres. You can use tools like Prometheus, which we talked about. And so I think this ecosystem is one of the biggest values that I personally see with Timescale. I think the other thing is, just to get into the weeds a little bit more, if you want to look into performance, we did this really detailed benchmarking exercise on influx, and we don't actually outperform influx on every single query. But what we do outperform on is more complex queries. So if you have higher cardinality, you're doing more joins, you're doing more group buys, that's kind of when we start to outperform. The other thing is influx builds indexes differently and uses memory differently. And so I think the stability of influx is still something they're working on improving, whereas we're built on top of Postgres. We use the Postgres memory management mechanisms. We use the storage layer. So I think it's just it's really a preference in terms of kind of what you want to use. For Spark, what?
Do you have connectors for?
Yeah, I don't want to personally say it works because I have not tried it. But if it works with Postgres, it should work with us. I will say that the one caveat is sometimes, like for example, if you use an ORM and the ORM isn't batching writes, even if it's working, it might not be performant. So you just want to make sure that you think about the performance characteristics of the different tools you're using. So the question was around whether or not we integrate with Spark. And I haven't done it myself, so I don't want to say yes.
JDBC, ODBC.
Oh, they use the JDBC ODBC connector? Oh, yes, then we do support JDBC ODBC. Yes. All right, that's it for me. Thank you. Thank you, everybody.
Great job, Diana, as always, on everything you do. Oh, you unplugged. Well, you can unplug, it's fine. Let's another round of applause for Diana, that was great. And it wouldn't have been a live demo without the database like growing legs and running away from her. We're gonna hang out for a little longer here. We're gonna try to scarf down more pizza and chug more beers. You don't have to chug more beers, but I might. But we're definitely gonna go to, I mean, for anyone that's doesn't have a long commute home, we're gonna head to Finn's Broom Street Pub, which is 2 streets east, and Tyler's getting excited about that. It's a cool pub, so we'd love to keep answering any questions and learning more about the work you guys do, and if Timescale could help out with that. So yeah, join us if you can. Thanks.